Okay. There it is, it's right here. So this question here would be more like sine rule. But how would we identify that? Well, to use sine rule, this one on here, it's more like, if you look on the diagram here, this angle here would belong with that side there. This angle here will belong with that side there. Can you see that? It's kind of like a crisscross pattern. That's the way you see it. If you look at this triangle over here, you can see that this angle belongs with that side, and this angle here belongs with that side. That's how you use sine rule. Okay, go? Yeah. So it doesn't matter really which one you use. In the textbook, it's pretty much the same thing. But the way I like to look at it is that if you're trying to find a side, you prefer to use this one, saves you one step. But if you're trying to find the angle, you use the one on the top. Doesn't matter which one you use, okay? Trying to find the distance. So we're trying to find like A or B, doesn't matter. So the way to do this is you put X on top of the angle that forms it, which is sine 123 is equal to 12.2 all over sine 19. Any questions there so far? That's just applying the formula. There's no tricks here. In this case, we have to make x the subject. So what is this number doing to the x? It's dividing. What's opposite dividing? Timesing. So you just times that directly up. So you get something like x is equal to 12.2 times sine bracket 123 degrees all over sine 19, and you punch all that into your calculator and that's it. Okay. 12.2 sine 123 degrees all over sine 19. We get 31.427. Is there a description? Yeah, they wanted to 2 decimal places, so you just approximate it. Approximately 31.43 meters bracket 2dp. Any questions there? All right, same trick with the other question. It's a side question, so go x all over the side that it belongs to. Oh, sorry, the angle. Sine 21 is equal to 9 all over sine 57. And you ask yourself the same question, well, what's sine 21 doing to the x? Is dividing, what's up with that? You multiply, so that goes up. And to be honest, girls, it's very mechanical work. Once you know the formula, you can just punch it right into the calculator. That's it. And that's it. You just punch that right into the calculator. 9 sine 21 all over sine 57. And then you get 3.845. Sorry, the angle? Yeah, we'll get to the angle. It's not an issue. 3.85 meters bracket 2dp. So sides is no issue, right? We can move on to the angle now. Angle would be like, say something like this, right? Find the sides of xwy. Xwy will be this thing here. The funny thing here is that we don't even have to use sine rule. This is a geometry problem. Because if you look closely, if you were to apply sine rule here, the issue is that there is no distance here, because if you use this angle goes towards this side, can you see there's no value here? So there's no point using sine rule at all. In fact, the easy way to do this is that you have to acknowledge that this triangle has two known sides already. Two known angles already. So we know that 3 angles added all together inside a triangle must add up to what value? 180, exactly. So we've got question mark plus 31 must all add up to 180. That gives you what? Well, question mark gives you 180, subtract whatever that is. Was that 53? Yeah, 53. You evaluate that. What is that? Trust the calculator. 127. Any issues with that? No, that's just geometry, right? So the answer for angle x cubed xyz is 127. That's the reason. Angle sum of triangle. Then it says find the length of xz, which is this distance here. So what can we use now? We could use sine rule now. Because now we know this angle, we have to find this side. So we could say xz is all over. What's the angle that it belongs to? What do you think? Yeah, and what's the angle of that? What's the value? 127, the one that we just found. So we could say sine 127 is equal to, now we need another one. We need another this. So what side can we use? We could use this side, 5. But 5 meters goes to what angle? That's right. So it'll be 5 all over sine 22. And then we're back to square 1. What do you have to do with sine 127? Well, sine 127 divided xz, we're going to multiply it up. So that just goes up. Xz is equal to 5 times sine 127 all over sine 22. And there we have it. Just calculator work at that point. Any questions? 127, sine 22. What's mine? 10.659, which is approximately 10.66 meters bracket CDP. All good to move on? Okay. So your question was find the angle. This is the case where we have to find the angle now. Finding angle is no different to finding the side, except that you just have to do one more extra step. We have to inverse the sine. That's literally it. So let's use the same trick here. Can you see that this theta here is unknown? That has no value. So what we do is that this theta here goes to that value, and this angle goes towards this value. Yeah, easy as that. So it becomes sine theta all over 9 is equal to sine 142 all over 15. We work out the algebra, and we can see that 9 is dividing sine theta. We want to multiply that up. So it becomes 9 sine 142 all over 15. Now the last step here, girls, is that we want to solve for theta, not sine theta. So we have to get rid of sine somehow. So we do not want to multiply or divide sine because sine is technically owning the theta. So what you do on your calculator is that you go, which goes into shift inverse, sine inverse, right? So you go theta sine inverse, open bracket, 9 times sine 142 all over 15. So it's quite a lot when you type that up in the calculator, but that's how you evaluate the angle. And then once you evaluate the angle, you press the bubble button, convert into degrees, and that's it. Easy as that. 9 times sine 142, 15, divide that. It's got 26.678. When you press that button, you get approximately 21 degrees, 40 minutes. So it's called sine rule because you're obviously using sine. You're not using any other angle. Does that make sense? Oh, sorry, not any other trigonometric function. you want to have a go at question D afterwards? Like, see how it goes? Can I have a look? You had an extra bracket at the front. Is everything okay right there? Yeah. I think the question says round up to the nearest degree. 40 minutes is enough to round up to the nearest degree. But let's just say what the question wants. Yeah, nearest degree. So 40 minutes is enough to round up the degree. Yeah. Yeah. Yeah, that's right. And then the final step will be cosine inverse. That's it. Alrighty, girls. I think that's pretty much it with sine rule. If you girls are okay with that, we can move on to the sine rule, and then we can move on to cosine rule. You notice already that the formula is a little bit more crazy looking, and the method of approach. Really? So the formula is not like, too scary looking, like, what's the order, A and B is okay. The way you solve this is not using sine rule, it's using the capital V method like I described. So if I was to illustrate the diagram. So that's how you use cosine sine rule. It's like a capital V method, kind of like an arching sort of thing. And to use sine rule, it's crisscross. The way to use this formula is the same thing as cosine sine rule, or cosine rule. To use this formula. So if you know how to use these, this should be no problem. So we could do a practical example, question 1b, for a good exercise. See how A is there? Just treat A as c squared. So when we do that, a squared is equal to 16 squared plus 9 squared minus 2 bracket 16 times 9 cosine 130. Try to squeeze it all in. So it's 130. Yep. Then you do a is equal to the square root of all of that. Times 9 cosine 130. We get 522.1228, and you take the square root of that. A is equal to, 22.85 centimeters to dp. questions? Okay. It's honestly just very mechanical work. If you know how to use the formula, it's very straightforward. No problem so far? Cosine settle? For which one? I got 22.85. Is everything okay? You want me to evaluate for it? Yeah, it's got to 2 there. 2 times 80. And then what you do, you just do square root answer. That's all you do.
Yeah, that's what I did.
Is everything okay here? Okay. Yeah. This one is using so what you do is kind of like that. So C is always the other side, so this case is 4. And then these two sides come down and put it over. That's okay. That will be the Sorry? That's X. So you have to find X. Which the way you have to use? Okay, the way you have to use this is because you have to get X, you have to use this angle. And we know it's the one across. Yeah, it's the one across. So you go like that, go across. That's the angle. So that's the side, and that's the side. So you have to do that. Okay. No, because 87 will be like this, right? And then if you do the capital D on that, you find this side, but that's not what the question is asking about. Yeah. I think C was last week's question. I didn't do that. I know that Sam's writing.
5.19.
Yep. Yeah, kind of does. Bianchi, is that the same answer that you got? Yeah, sweet. Yeah, it's the same thing here. And then after this next page, you just go into this new formula. They're running a triangle, non-running a triangle, sorry. You don't have to do all the questions there. It's very, very copy and paste. Just like do two of your choice, and then we'll just move on. Yeah, because it's the same method. That's it. Same method, different numbers.
Would you get for 2B?
Yeah, just do two.
2B. Okay, so okay. Okay, I need it on my phone. Okay. I will enter it.
2b.
Yeah.
Let's have a look. 13.02. Did you get that? Did you get 10 on the first answer?
Yeah.
Yeah, Pythagoras' theorem. And then you just plug it in just carefully. That's it. All right. You girls having trouble?
The second one because I was 4 degrees.
That's 4 degrees, that's correct. Not necessarily. In this
Can I
case,
just put any numbers anyway?
again, this topic is all about perspective. So C, A, B doesn't really have any significant length values. So if you're trying to find, like, say for example, like this thing here, right? Well, then you just look at this perspective. Then this becomes your AB, and this becomes your C. And if you want to look at this perspective, well, that's C, that's B. And if you look at this perspective, well, then this becomes your A and B, that becomes your C. So there's no intrinsic values for C and cosine C. It's just like all about perspective. Ooh, 800 degrees. Huh? Right. Which one did you do? 50 degrees. 84 squared, 59 squared minus 65 squared over 2 times 59 times. Yeah. What? Show me. Because you didn't do cosine side, cosine inverse. Yeah, so you just did that, but you have to find C, so you chuck cosine onto the other side.
So does it look like when we go and calculate?
Cosine inverse. That's what you have to do. Just press equal on that. Yeah,
So
just
we have
cosine.
to put it all in.
Yeah. So the end process of this is if you just get really used to these formulas, you don't have to start at the very beginning. You can just jump right into the square root and jump right into the cosine inverse. Save yourself some time in the exam, you know what I mean? Okay. Cosine CAB. Squared plus squared minus squared. Are you going up to my question? Sorry.
So what's the difference from doing like all these ones or just plugging in?
Okay, let me have that. That question there is asking a very specific angle. asking for angle ABC, and angle ABC is here, which is evaluating that angle. Once you evaluate that angle, you move on to the next one, which is asking for CAB, which is position.
Yeah, but like, what's the difference from like, I thought it didn't matter what it's minus and everything.
Well, because in this side, you will minus the 10 square, but if you're looking from this angle, you won't be minus the 10 square, you will be minus
So
the
it
8
does
square.
matter what.
Yeah, it's all about perspective, remember? It's all about the capital V method. If you're doing capital V method on this side, there'll be a C. If you do capital V method on this side, there'll be a C. And then lastly, if you do capital V on this side, there'll be a C. Does that make sense? So, okay, so in this case, cosine C is going to be A and B will be the two sides next to the angle. Doesn't matter which one they are. This will be A, this will be B, doesn't matter which one it is. As long as C is the one that's opposite to the angle.
Oh, okay.
Okay. And if, let's just say hypothetically, when it's also alpha, then this becomes a C. Because this, and then because alpha will be looking this way,
Oh, okay.
and if it was gamma, then this becomes a C. This becomes A, this becomes A.
Okay.
So that, as you can see, it's very straightforward. Just capital V. Yeah. That's it. That's it. Well, well done. So you know how to hold up.
Yeah. So that formula is the next bit?
I think so. Did I read that correctly? Yeah, area of a triangle is this one here. It's the area of a triangle. I'll write the formula up.
So opposite by 2 degrees is it still that B?
Yep. To use this formula here, it's same thing as cosine side rule, cosine angle, same thing. I'll show you trial one. Because you're using this angle here, you're looking this way. Oh, you're looking that way. That's it. From area is equal to half times 5 times 6 times sine 60, and that's it. Chuck it all into the calculator and you're done. $80 degrees? Yeah, 80 degrees, that's correct. Oh, this is area as well, Bianca, so make sure you put centimeters squared.
Oh, wait, you do
What is the size? Just looking at
This one here, there's two ways you can solve it. One, you can do it the normal way, you still get it correct, or you can use the geometric way where two angles add up together and then you find the last angle, you evaluate the last angle using angle sum triangle, okay? Yeah. The next page is a new formula, this one here. D is an interesting question. I think I recommend everyone doing that. But A, B, and C is pretty much the same thing. At first glance, D might look like sine rule, right? Yeah, and then you could use 7.26 and 9.3 as your A and B, and then you could evaluate the angle that way. Sorry, evaluate the area that way. Yeah, that's correct. Minus. Okay, well, look, I'm writing out the answers technically right now, so I'll just put myself back to square one to give you an idea, like why I'm doing it. Okay? So your question was, which angle do I have to use? Well, if we use this angle here, if we go up, I'm happy with that. If we go across, Can you see how this side here I have a value, and on this side here I don't have a value? I can't use area sign. I can't use this formula here because I'm missing that b component. So I can't use that. And if you did it the other way, where you go this angle and this side, I've got that side, but I don't have this side. So I hit an issue here. The correct way to solve this problem is evaluating this angle here, and then use these two sides here, which they gave us. But the real question is, how do you solve for ACB? Well, ACB is just angles on a triangle. So ACB is just 180, subtract 31, subtract 45, and just punch that right into the calculator. 31. Whoa. What was your question?
Oh no, I said the answer.
104?
Yeah.
Yeah, thank you.
No worries.
And then, and then you can just plug it in. AB sine C half 7.26 times 9.3 sine 104. There you go. No, just this. What am I hearing right now?
I think he's in the special.
33 centimeters squared. That's essentially all the formulas that you need to know for non-right angle trigonometry. The rest of the document is just bearings. Like, you know, it's all about that compass stuff. That's it. Yeah, that's it.
Yeah, and it's just it's specifically non-blind.
Yeah, subtower. Oh, okay. Find the area parallelogram. Oh, wow. This one here is not too bad. You just find one area of the triangle and then just times it by 2. Sorry, what? Oh, yeah. So what you can do with B is that you go that will be your angle. These will be two sides. You evaluate the angle and then you just times that by 2, and then that's it. Easy peasy. So just do one of the two and then just move on. We'll do 3. Yeah, we'll definitely do it. Question 3 is working backwards. So I'll give you time just to do. I'll just do one off. Sorry, what's the answer to question 3?
No.
Oh. Yep. Yep. So question 3, once you guys catch up, is an example of working backwards. Because they already gave us the area, we have to find the side. So this is when like a little bit of algebra comes in, a little bit, not so much. Let's just start off with writing out the formula again. Half AB sine C. Okay. So here's our triangle. We have to look this way. All right. We have to find the question mark, which is AC. So we could just substitute that with any letter you want. Let's just say X for simplicity. Okay. And we just go, area is already given to us, it's 52.5. So we go 52.5 half times 14 times X times sine 60. Okay? Oh, 30. Happy with that? Now, this is when you could just like type into the calculator sine times, sorry, 14 times half times sine 30. What does that equal to? Should give you a nice number. Yeah, 3.5. So all of that on this side gives you the 3.5. 3.5 times x, 52.5. And what is 3.5 doing to the x? It's multiplying, so that just implies division. 52.5 divided by 3.5. What is that? 52.5 divided by the answer. It gives me 15. So that means the other side is 15 centimeters. That's it. And because it's length, you don't write centimeters, 15 centimeters squared. It's actually, the funny thing is I wrote 15 centimeters squared. It's just 15 centimeters because it's just distance, okay? How was that question? Not too bad. So again, just like with mathematics, if you know how to work forward with the formula, you need to know how to work backwards with the formula too, okay? All right, we've got miscellaneous problem. Miscellaneous problem just means that for everything that you've learned, it could be anything, that's right. And also we have to draw up the triangle just in case it really needs to. I don't mind doing a couple. Based on the design of the triangle overall. So in triangle ABC, let's just draw that up. Could be random. I'll say A, capital B, capital C. Little a is 2.5. So remember, opposite of capital A is 2.5, because that's little a. Opposite of little capital B is B, so be 3 here. And opposite of capital C is little c, so it'll be 4 centimeters here. Okay? And then the question here says find an angle of just capital A, so we just have to find this thing here. We could just call that theta. And from the looks of it, yep, that's definitely cosine. Well, cosine is capital V, and for sine rule, you need to use crisscross. The way to use crisscross, you need at least 2 angles. We're only given 1 angle here.
Oh, okay. So
Yeah.
2 angles for sine, 1 angle.
Yeah, that's right, yeah. But like, I want you girls to really get familiar with these formulas, not relying on like on patterns. So when you do these questions, you could just like instantly know that's cosine rule or sine rule, stuff like that. Okay. Could just evaluate it. So I'm just gonna chuck it all in one go. Yeah. Nearest degree. First question was okay? Not too much. Do you want to have a go at question B, construct your own triangle, try to understand it? Yeah. Because this will be the skills part of mathematics. I'm reading the question, trying to draw up your own diagram, make sure you understand. Yeah. When you read the question, you're given two angles, you're given one known side, and you're given one unknown side. Most likely sounds unknown. Yeah. So which one would you think?
The second.
Yeah. Yeah. Now look, don't get me wrong. You can still find side using this formula here. You can still use find side, but you're just costing yourself one extra step, which could cost time. I don't know, but like you go fast, you could make up for that. I just shortcut it. Okay? Okay, so triangle could look something random like this. A, B, C. Angle A is 75. Yeah. Angle B is 38. Like that. Little a is 14.7, and find B, so B is like this. You having fun? And that's it. 14.7 sine 38, sine 75. Yeah, there we go. 9.36 centimeters cubic feet. Well, actually, it's rounding up, so it'd be 7. Okay. Whoa, what on earth is this? So, in the figure below, not the scale, you've got all these numbers here. Use sine rule to find A and cosine rule to find B. Okay, well, first of all, in the HSC exam, they won't give it out like that, okay? They literally just told you the instructions how to do this question. It's not like that for the HSC, alright? But this style of question could be asked, but not in the way this should be asked. Oh, just by the way, girls, everyone, in the exam, don't assume right angle. Don't assume that's a right angle box right there. So that's the last thing you want to do is like put a little box in and say SOHCAHTOA is a thing. Don't do that, okay? Only if the box is given to you, then you can use SOHCAHTOA. But even that looks really, really nice to be a right angle, don't put a box there. What's that? Composite triangles and bearings. Okay. Does anyone need help with this question?
I'll figure it out.
Well, you're right to choose 87 as your angle. So that should help you with A, well, like little a when you solve it. Oh, you're doing B now, okay.
What's the answer for the sine?
I didn't do it, so I'm letting this question entirely up to you guys. Define B.
Yeah, sine B.
If you're gonna find R.
If it's sometimes confusing which one's which, the little letter is most likely the side, and the capital C, most likely angle. And anything that's a little case, they're always sides. You don't.
We have to look it up.
You have to look at outward facing.
Oh, Pythagoras, you're assuming that triangle is right angle. Yeah, so we don't want to be in that case. So the real case is, I mean, it tells you have to use cosine rule in the question anyways. Okay, so I'll just, what's the value of A? Did you girls get? Just 8? Oh, wow.
Last of the one.
Wait, what? That's it. So I'm using this answer that you girls solve as part of this problem. Okay? Does it make sense? Do you see how that answer in part I carries over to the second triangle? So, in other words, if you don't do part A correctly, and you carry through that answer incorrectly, then you're going to make a cascade of effects that's not going to look good.
So if I'm trying to find B,
Yeah?
you use the angle opposite.
Yeah. Okay, I'm going to catch up, alright? I haven't seen it yet. What was the last topic? Yeah, 365. 3. Yeah. Alright. Okay. Topic, so the no? Okay. We're good. Save it now. You're 4.9? Well done. Yeah, these questions here, they're the style of HSC, definitely. Yeah, but except they don't tell you instructions at the beginning. That's it.
Just shows you the picture, it's like work it out.
That's it, yeah.
You're gonna do that.
I have like this one paper. They did it today.
Yeah.
That's what I first remember.
Our math teacher was like looking at it, was like,
I haven't met someone. I haven't met one person.
That's just screwed over everyone.
Same with the
right?
English
And my
paper.
teacher was
No.
like, yeah, you know, this paper was written before the whole COVID thing happened. I was like, and they didn't think to refine it for the 4 year 12s that went through the whole COVID thing.
Yeah, it's
Like, okay, I get it
wrong.
was written before it, but surely they would have been like, maybe we should rewrite it since they've had a really bad year.
yeah, it's what a way to go, right? All right, the next question, miscellaneous problems number. They technically gave you the form that you have to get to, so you're not trying to solve. You're just trying to show that you will get to this. So. So we can see that this triangle here, we're going to work inside this blue triangle. A B is here. So this angle here most likely goes to that. And we need another angle, because if we go this way, there's nothing there, so we can't go that way. So we get rid of that pathway. What we can do is we could put something relating to 120, so we have to find the angle at the very top here. And to evaluate that, we just do angles on the triangle, that's it. So we could say angle A is equal to 180 minus, yeah, 32. And then you just write, what is it? E all over sine 38 is equal to 120 all over sine 32. And the only thing you have to do here is just bring sine 38 up because you're multiplying, and then you already got the form. That's it. So actually, part A and part B goes together because part B just says hence find value of B. So you just punch all that into the calculator. So you just get 120 times sine 38 all over sine 32. Next part, you just punch it all into the calculator. Sine 32 is equal to 139.416, approximately 139.42 meters, bracket 2dp. Use the right angle triangle ADC to find the value of h to two decimal places. Oh, okay, well that's just self-told then. So the question says if we're given a right angle triangle, so we actually no longer have an equally equations, you just have to use SOHCAHTOA, that's it. Oh no, that's not very SOHCAHTOA. That's easy.
Forget the easy stuff and doing all the
I know, that's
all the other stuff.
it's sine, opposite of hypotenuse. How? Oh no. So, okay, let's see. Use a different color. So we're using this angle, goes to that, that's opposite, then opposite goes to hypotenuse, and obviously hypotenuse is little b, because we already found little b. So it will be, there it is, sine 70 is equal to h on b, but we already found b, so it's okay, we could just replace that. What is b doing to the h? It's dividing that. So to finally evaluate that, it's just 139.42 times sine 70. And that's it, done. So that gives us 131.01 meters, bracket 2 degree. Not too bad, yeah? All right, let's move on. Okay, it looks like it's slowly introducing bearings. How are you girls with bearings? Are you girls okay? That's right. So there's two types of bearings. There's true bearing, where it just rotates all the way around. And the other one is compass bearing, where it gives you a specific quadrant that you're going to be playing around with. I'll give you a little introduction. So just remind you. True bearing starts north and rotates clockwise. That's it. So let's say, for example, 120 degrees, so go all the way around and stop around there. That's about 120 degrees. Choose another number between 0 to 360. You know what you want?
137.
137. Okay, 137. Just leave up there.
Yes.
Yeah, that's approximate. I mean, don't be bothered to bring a protractor. I mean, if you want to bring a protractor, go ahead, but you're just wasting time. So just to remember that this is 0, 90, 180, 270, and 360 up here again for one revolution. Okay? So true bearing is just, you start up here and you just rotate all the way around clockwise. You don't go clockwise. The other one that you have to remember is compass bearing. This one's a little bit more specific.
What kind of question do you get?
It's not on this page. I think the next page is kind of like that. Yeah, it's kind of like this. And this,
So would
yeah.
the true bearing be like?
True bearing is, true bearing is like you just find the angle. The issue here is not as straightforward because it depends on the question, what the question is asking for. See how a question says, for the diagram, write down the true bearing of Q from P. The issue here is the language. We always say from. So say, for example, let's just say this is town A, and let's just say this is town B, for example. Okay. Now, the bearing from A, in your HSC, you always have to look from. And from means I want to look from here. So from A, the answer is literally just that, 120. But if the question says from B, you have to draw another compass bearing on B and work out that.
I hated it.
I know. Pain's coming in, I get it.
I'll
draw
what
up
are
there.
you even finding at that point?
You have to find the bearings. So do you girls remember pointeria from maybe year 7 geometry? Pointeria angles when you have two lines that are parallel. Then X goes there, Y goes here, X plus Y.
7.
Well, I hope so. So if that's 120, that must be 60.
I do not love 97.
Okay, maybe 8 then.
I've never lived that life.
Well, if that's 60, then what's the remaining angle? Must be 300.
Definitely the
So from B, it's 300 degrees. From. That's it. Yeah, that's starting point. So from A, oh, that's easy. No worries. From A is just 120 degrees. But, okay. But if it says from B, you draw a compass bearing on B, and you work that angle.
They'd be like, this is like science. I bet they
Yeah, they do that stuff.
when they go to the moon.
Well, yeah. You think they orientate themselves?
Oh my.
All right, let's do these questions again, okay? So in the diagram, PQR represents 3 towns. Town P is 25 kilometers due west. Now, in the question when it says due west, it literally just due west. No angle up or angle down. It just goes west. Of town Q. The bearing from P from R is 0, 18 degrees. So P from R here, if you go all the way that is 18 degrees in there. And of Q from R, so from R, it is 48 degrees from Q. That this angle here in blue, because it says the town of P from R. So you're looking at P from R, it's 18. So this is that. You know, I should have color coded this properly. I should have done that in red. So just focus here. We'll do this question together, okay? So P from R, 18 degrees is looking from here, but it says from R, that's connecting to P, that's 18. Yeah. Oh, okay. Well, the next part here I'll do in blue so you can see how to differentiate between those two angles. Where is it? Here it is. Q from R is 0.48 degrees, so it's from Q from R, you rotate all the way around here, and that gives us 48 degrees. Not too bad so far, right? Any other values we're given? So it says here, find the size of PRQ. PRQ is, you have to find theta. Yeah, which is 30 degrees. So angle PRQ equals 48 degrees, subtract 18 degrees, 30 degrees. I'm happy with that. Find the size of PQR. PQR, which is this one here. You have to find, where's my mouse? Okay. You have to find this one here. What can we do? Particularly in this question, when it asks you to find an angle somewhere else, the good hint is to draw another compass bearing on that position. And hopefully that will give you some hint to solve it. So it says find the angle of PQR. Well, it's here, so let's try to figure this one out. So we know this entire angle here is 48 degrees. Do you go to acknowledge that? All right, now I'm going to do a little bit of geometry here. Your geometry skills has to be really, really good here to do this type of questions, okay? So let's use quinteria. This whole angle here is just like that problem there. X is 48, Y is that unknown. So let's solve for that unknown. Why? Because of this sort of quinteria angle here. Can you see that? No. You're looking at that and I was like, so that's 48 plus some unknown angle equals to 180. Unknown angle equals 180, subtract 48. What is that mysterious value? It's 132. Now, you think it's over? It's not over yet. Where the heck is my mouse? There it is. So you can see that the green angle here is 132 degrees, which is encompasses this whole value, but we only want the blue angle, which is in here. But you go back to quadrants and you realize that quadrants in a bearing, we know that's 90 degrees. We got 90 degrees there. So something plus 90 gives you 132. We can find that blue angle there. So we get 132 minus 90 gives you, oh my god, what value is that? 42 degrees, and that's the answer.
I'm so happy.
Do you get it?
I do.
Does anyone else get it? Okay. There's two types of parallel concepts you have to remember with these type of questions. It's quinteria, that's the first one.
Oh, it looks like okay.
And the other one is an alternate angles.
So that's the first part of the question.
That's just B.
So how do we know
What?
the angle?
So can we do 132 minus something?
90 minus 90. Why? Because each bearing.
Yeah, but why is it line here?
Because of this property here. Pointerior. If you flip that to this side, you'll get that diagram in green. You just take your time with these questions, okay?
Okay, why is it 132 minus 90?
Because each quadrant inside a circle, 90, 90, 90, 90, 90 times 4, 360, we have this little angle here, we already know that's 90. 90 plus some angle gives you 132, subtract that value off, you get 42 degrees done. Yeah, that's what we're trying to find.
Oh, and what's AB?
We're not trying to find that.
You don't even know all that?
No.
Why is that 132 minus 90?
You want me to explain it again from the start? From the start? Okay. I hope the color code's helping out because like if it's all blue then it might be a little bit harder to see, okay? So I'll start from the start again. So to find the size of PRQ, do all you know how to solve that? That's just 48 minus 18.
Yeah, I got that part.
Okay, sweet. We can continue from there, okay? Now we have to solve for PQR, which is only this orange part. Let's just color code that properly. It's orange, okay? We're only concerned about that part there. Now, what comes to my attention is we want to establish pointerior, which is this really big looking capital green C. Can you see that? When you think of pointerior, you know two angles must add up together to give you 180 degrees. We know one angle is 48 degrees. We're trying to find the other angle. To find the other angle, we do a simple subtraction on 180. 180 subtracts 48 gives you 132 degrees, which is that really big green arc at the very top. Can you see that?
So what's 130 degrees? What angle is that?
That's all this green thing here. That's this whole green thing here.
What is it called?
Yeah, that's all 132. But inside 132 is the angle that we're trying to find.
Okay.
And there's one more hint.
Makes sense.
We got a quadrant. So 90 plus an unknown gives you 132. We can also find that unknown. Just turns out to be 42 degrees. The angle in orange, yeah. So I'll write the overall working out here. So you've got 180 subtract 48, which gives you 132, and I'll give you the reason it's pointerior.
What about this thing? I don't know.
No. Here, I'll show you.
This is like all 180.
I'm trying to find this piece, right? Yeah. And let's just call this unknown because this piece plus this place must give you what? But what is this? 9. 90 plus unknown must give you 132. 132 minus 90 gives you 42. Now, I don't want to be a buzzkill. There's actually a lot easier way to do this. There's always an easy way in mathematics skills, okay? If just because I teach you one way doesn't mean like, oh, this must be the only way. There's actually an easy way to do this.
The other way. Oh, the ultimate.
Once I show you this one, you're like, oh my god.
What? Where's the Z?
I'll draw it in and you'll see it.
Oh, is it here?
It's like
Yeah,
this. So can you see that, Gil? We're trying to find alpha, but alpha matches up with alpha here. So once you find alpha, straight away.
Oh.
What?
So can you go see that?
I got the Z.
Yeah, so if you evaluate alpha, you could get alpha. Okay, so just take your time with these questions, and the only way to get good at these questions is that you have to do a lot, like a lot. Oh, I've got to wrap up soon. I was just getting good with bearings, man. I was just getting good.
Yeah.
Bianca, is everything okay? Yeah? There's always a hard way, there's an
Oh
easy
wow.
way to solve.
So I don't get that. I know.
Yeah.
You just need to put it through and it's one less step of what you said. So you can see it easier.
Okay, I'll solve the last question, then I'll wrap things up, and then Sam takes over. All right?
We just got good.
Yeah, it
We
starts.
just got good.
These questions are.
You know how like you're confused and something just makes sense and you're like, whoa.
Yeah.
That's what just happened.
Oh, okay.
I don't have any
It says find distance
waiting for
P to R. P to R. Oh, we're just finding distance. There's a lot of color codes here, so we have to find P to R. Let's use red. We have to find this whole distance here in red. So I'll draw it out again using all the hints that we've solved. So this would be 30. This would be 42 as we solved already. This would be 25 kilometers, and this would be question mark. Ah, well, what rule do we have to use here? It's sine rule. Because we're trying to find question mark. This side, this angle goes to that side, this angle goes to that side. It's sine rule. That's it. So question mark over sine 42 is equal to 25 kilometers over sine 30. That's it, done. 25 times sine 42 over sine 30, and that's it. You punch it all into your calculator, you're done. But does it make you understand it though? So, it's all good then. 33.45. 33.456 kilometers. So we just approximate that. Roughly 33.46 kilometers bracket 2. Okay. Unless I rush it, let me just try to think. So that goes to that. Oh, 30 is from the very beginning. Yeah, 30 is from the very beginning, not 48. Yeah. So the most important thing that everyone can take from this lesson is that it's all about from, okay? From A, from what letter? From B. Yeah. I'll probably just do a couple of questions here, then I'll probably go, okay? So in this case, it says, for each diagram, write down the true bearing Q from P. Okay, so if it says Q from P, oh, this one's easy. This one's just straight up 126. So the angle is 126 degrees T. Q from P, that's this thing here. So that's 360 minus 130, gives you 230 degrees T. This one from P, you got to do another compass thing here, go all the way around. Yeah, C is a little bit more working out actually. How would you girls solve C? Think about it. Try to use every. It could be that, yeah. 51 is on that side, so you have to use quinterial to find red. And then 360 minus red gives you blue.
So we're trying to find red, right?
No, we're trying to find blue. So 180 minus 51 gives you 129. 360 minus 129 gives you blue. Now that's one way. The other way is using alternate. So I'll draw alternate in. It's like the capital N.
But if it's 1P, why is that in there?
Oh, I wrote the question wrong.
I was gonna say, I'm like, whoa.
Alright, sorry girls. But anyways, this is good practice, okay? This is good practice. It's, no, it's 51. The question is, yeah, okay, I mucked that one up real bad. The answer is 51 degrees T. Yeah. Alright guys, I'm gonna wrap up, yeah.
Do we have to put the 0 for the
Yes.
Wait, so is that the answer, the wrong answer or the right answer?
No, the green one is the correct answer, but if I was to keep on going, you'll be solving from Q, not from P.
And he's starting from Q. You know the one you Yeah, I think.
Yeah, the green working out is correct. That's it. Q from P. It's all about from P. I'm gonna write that. This is the later part of trigonometry, so you don't get it. Why? What's going on? Show me. Which question? Which question is it?
Oh, I'm not reading it. Wait, what is it again? I'm so confused. I don't understand what
Let's just give up the whole time.
Sam should like cover this thing because this is the last part of trigonometry. Let me just see what's up. Oh yeah. Oh, compass bearing. Yeah, I didn't have time to explain that. Oh man.
I'm looking at it like this.
And then topic is yeah. Which one? This green one here?
It's the pink.
Yeah.
Because from P. That's what I'm looking at.
Not like that. From P literally means from P. So from P means you just look at one. I'll get Sam and then he'll clarify a couple of
Right,
things.
so for D,
Yeah.
it says so it's from P. So would you go around and do 360 minus?
That's correct, yes. Yeah. Because why? Clockwise.
Yeah.
I didn't have enough time to explain compass. The next few questions could be compass bearing, so just ask Sam to explain compass bearing. Compass bearing, you don't work like this. You work in 90-degree intervals. Oh my god, there's something in here. So you have north, south, east, west, and if the angle's in here, you say north, blah, east. If the angle's in here, then you go south, blah, east. If the angle's in here, you go south, blah, west. And lastly, if the angle's in here, you go north, blah, west. That's the other one. Okay, I'm gonna wrap it up now, alright? Was everything making sense up until there? Okay, then I think, you know what, we could just spend one more lesson on this next week and that's trigonometry wrapped up. I think we just talk to Sam about that.
Let's just only do financial. I like
Financial math is a huge component of this. All about the money,
I
all about
love
money,
my favorite unit.
compound interest, depreciation, straight line depreciation,
I failed every pathway.
find time.
I failed every pathway for exam except the one with
That sounds not good.
like I failed every.
Alright. There you go.
Bye. Thank you. This is the brightest feeling to not fail.
Is it? That's words. That's all. It's shot. Great, it's
Next week.
All right. You guys up to radial surveys? Just the one above. It's funny. One of my bearings one of my standard students called me up last night. Going, I don't know what radial surveys are. I'm like, okay, relax. We'll get it done in 2 seconds. He's like, oh, is that all it is? Yep. Oh, okay.
Question, are we not having one?
No, you're meant to. I just haven't been able to change these guys to the latest session. So it's either you guys got to go later or they're going to go later. Very likely you guys will have to go to the later session, which means you guys probably start at 5:30 instead of 4, which I didn't think you'll like, hence why I've kept it like this at this time until next year. You'll probably. And then because they were originally in this time slot before we had to go through all this changes and everything like that. You guys were in the Thursday class originally, and so on and so on. Doesn't matter. What can I do? Yeah, that's okay. I'll sort it out. I'm trying. Hence why I've got Daniel, I've got Alessandra and stuff. It's just
Everyone's switching around.
yeah. I'm trying.
So would we be 5:30 to 7:30?
If you want to have me, yes, put it like that. Otherwise, at the moment, it's going to keep going like this until I can get them moving, which is what I just asked Dad. Dad said it depends on their guitar teacher or piano teacher or something like that. That's, yeah. Or you could just come directly here, study here, until our lesson. That's
That's what I do when I get ready.
yeah.
Think about the food. Think about the food.
It's
And I
all
don't want
about
to spend
I want to
like,
get changed.
we don't want to spend $40 a week on Uber
I don't
Yeah,
even mind
no.
that because when I get home anyway, I just forget.
All right, let's keep going.
What if we have to
Talk, and do this.
You can receive and I see you.
Yes, I can. And the problem is, I need to pump that up. Just give me a second.
No, don't get confused because that was a whole, no, like that was a whole mistake. That was a mistake.
But I wouldn't actually do it because
It's just, it's your look from P. That's P, that's P, that's the answer. That's the thing. I was like, why are you doing Z's and crap? Like, that's just it. Race driver, am I done with trig variance? of Q from P. 51. Right there.
What is the T there?
Look,
Oh,
look at this one.
true.
Look, Q to P, 126, Q to P.
And then the next one, do we do 360 minus 48?
Why? What? Isn't it just 48?
No, because it's on the other side.
I don't like
Okay, realistically, I'm not gonna get lost in the jungle and I need to know my true bearing and now I'm wrong.
Yeah, but you're gonna take a math exam that's gonna have it on it.
Is it 222?
All right, let's have a look at this.
I got the same. I'm just in it.
Well, there is a really good way that you've got to see.
Excuse me?
Is that a shark?
There's a really good way you've got to see these bearings, and Daniel's pretty much showing it to you. It's all about alternate angles. So the one thing you want to take out of bearings is alternate angles. Everything starts from north as well. So at any point that you've got to draw your compass bearings. So if it was even at this stage, I would recommend drawing these little compass bearings. You should learn to do that. And then you can see your alternate angles a lot easier for the harder questions. These ones are really easy, so you might not need them as much, but let's keep going. You want me to do D now?
If you just you draw a line.
So like, look, I'm trying to say draw compass bearings. Instead of it just being north, draw it like this, and then you can see it starts from north to get to 48 degrees. It would be 360, take away 48. That's it. 312 degrees. Next one, same thing. Draw your compass bearings. That becomes 180 plus 24, 204 degrees. Next one, same thing to here. What would it be this time? 180 minus 32. .48 degrees. Easy. Let's move to some harder ones. So bearings number 2.
Let's not do dogs.
Well, let's move to these ones, these radial surveys.
That sounds complicated.
I know, but I'll make it easy, so pay attention because it will be in your HSC.
What won't it?
Oh, no, there are certain things like bearings won't be like that, but this specific question will be in your HSC.
Why
That's how it
would
works.
bearings not going to be in it?
Because this part is this is bearings.
Oh.
So it's not, you're not going to do those easy stuff that you just did. This will be the question you'll get.
Oh, so it's in it just fell off. That's what you're saying.
Pretty much. All right. I haven't seen today's paper yet because I've been so busy. I'm going to take it out right now.
Isn't there something about an insect?
Today's paper. I want
Yeah,
to see
so
it.
we'll look at it in a second. Diagram shows the results. The diagram shows the result of a compass radial survey conducted on an area of land. So a survey is just like those guys you see outside that are they've got the little triangle thing out on the street, and they've got a little binocular thing they look through. They look at the contours of the roads.
No.
They're called surveyors. Yeah, you've seen them. You just probably haven't paid attention. No.
Are they like trading or something?
No. Oh, I guess so, maybe. But anyways, so what they do, this is like a drawing of I guess let's just say a road, if you want to say that. This is an intersection. This is road A, road B, road C, and it pretty much says the angle that road is going at, and it says the length of that road. Fair enough. So think of it as a little snapshot of a map of a road or whatever. So what do all these numbers represent? 40 degrees, 145 degrees, 260 degrees. That's really weird. But the way it works is you draw your bearings. B is 40 degrees from north. Can we see it now? That angle there is what? That angle there must be? That angle there,
Which one?
oh, sorry, can't see it. That angle there,
Oh, that must be 50.
No.
Right? Wait, no.
the length is 50. Angle must be to this line, 40
What's
degrees.
40? What's that? Where's that?
40 degrees, okay. Let's do it again. Let's do another one. I think
Oh,
you'll get
wait,
it.
the other side's 50.
I think you'll see it a little bit better when you see the next one. From north
Yeah.
to sea. From
Yeah.
north to sea, what angle is it? These numbers down here, 145, that's what they're there for.
Wow.
Right, from north all the way to here,
260.
260,
Oh, so
I
from
see.
north to that line.
would be
is
40 degrees, correct.
Okay. That would be the first hour. There you
So
go.
look, this is 40 degrees, this is 145 degrees. Can you see it now? Or no, still not? Hey, this is 260.
Dolly's having like a mental. Just collapse.
That usually helps.
Dolly is a special kind.
All right, wait, one more
Yeah,
time.
look at me now.
So there's your compass bearings from P all the way to this line here. The angle is here, 40 degrees. From north to the angle of C, or the line C, or the road C, it is at an angle of 145 degrees. We understand that? So if I ask you now to find this angle in here, BPC, how would you work that out? 145 minus 40. You got to stop looking at your side lengths. You keep saying 50. Are you looking at the right question?
Yeah, because it's a 90-degree angle on the other side of it's.
Oh, like that. Sorry, yes. I understand now. I think it's looking at the 50 meters. I'm like, you got to stop doing that. Right, I got you.
I'm not that stupid.
105 degrees. All right. Any questions there?
Nope.
No? Understand?
Let me just try to do it for myself because I don't know what's happening.
How are you gonna do it by yourself if you don't know what you're doing?
Figured it out last time.
Next one. Next one. Angle APC. Angle APC. How would you work out this angle in here? Angle APC. What should that be? What do you think? Again, think of it from north to A is 260. From north to C is 145. So then angle APC, that's it. That's all. I don't know what you're doing. You're making it seems like you're making it harder than it needs to be.
How are you overthinking
I
it?
know there's nothing to really overthink here.
What are you overthinking?
There's no thinking of highlighter color. I just confused yourself. Who's green?
Okay.
Just again.
That's what you've been saying for the past 10 minutes.
2 milliseconds past. I don't like this joke.
At a point, we're gonna stop giving you seconds and just tell you what to do.
Okay. Continue. Use the cosine rule to find the length of BC. I'll leave that with you girls. I'll just draw you a triangle. Let me help Dahlia out. So here it is. Find BC. You already know this is 50 meters. You know this is 92 meters. You know this angle is 105 degrees. Go and find this. Let's call it x. Easy? So you can see the hardest bit of this is literally the survey bit. And if you can understand it's just subtraction, then there's no problem. Yes. Now, it's asking to find BPC, this angle in here. BPC. To find that, from here to here is 40 degrees. That's what these numbers represent. That's what I'm saying.
Wait, so that's just labeling it.
Yes. I said
That
that.
was everything.
From here to here. Right. Is that all you needed? Just for me to say it's a label? Maybe I'll go use that word. Label.
Yeah.
You're using the C squared.
Yeah, this one.
This
That
one.
Yeah.
Cosine.
It's pretty understandable.
Matrices. All right, done?
Yeah.
X equals 115.3. Can't complain if everyone's with the same answer. Yep. Amen. Diagram. Anyone? Christian? Any questions?
Oh, no.
Question 2 then. Again, how do we read this? Look, there's your north. There's your east and west. That's 15 degrees. Hi, Rebecca's upstairs. Room 3. Room 3. If you want to study as well, I think the garage is empty actually. Until your class. 15 degrees.
Yeah.
True?
Yeah.
And then from here to here is 155 degrees. So if I ask you to find this angle in here, how would you find that? Between Q, O, and P. Minus 155 and 15, you'll get 140 degrees. Something like that. Cool. What does the question ask you to do now? Find ROQ. It would be ROQ. ROQ would be, come on, 260 minus 155. Right? Isn't it this? Look, if I draw it all the way to here, subtract all of this, you're left with this bit here. (105 degrees). Find the area of triangle ROQ. Find the area of the triangle. Which formula are you meant to use? A equals
half B.
what would A be? 68. B 75, I think it was. Sine, what's C? 105 degrees.
What was A and B again?
68 and 75.
Yeah.
Got it up yet.
I mean, I'm kind of worried about our head teachers, our math, seeing our math teacher was worried about some of those questions, and she's a math teacher.
Yeah, I know. They're saying it right now. What the foreign math one happening. Yeah. From teachers. They said the standard one wasn't good for their students.
Well, I even said earlier when.
But the advanced, which is what Mandy said, but advanced was apparently okay.
When Dave was just now saying like, because our math teacher said the exam was written before all like the COVID stuff happened, but I'm like,
Correct.
you'd think they'd be like, oh, a lot has happened this year.
You can't, they
missed
can't
out
do
on a
that.
lot.
It doesn't work like that.
Why?
It just doesn't work like that.
But that's not fair.
Security periods and printing and all this stuff, it just does not work.
But that's not fair.
Logistically, you cannot, because it's got to go through a fairly strict system to make sure that the paper itself is fair
Do you know who's very
across the board. Sorry? But why does it matter? Yeah, they were everything before. Sorry? No, but it doesn't matter, like what you're not understanding, or whoever talks like that, what they don't understand is there's always scaling. So even if 60% is the highest and it was the hardest exam, great, that 60% becomes 100. So it doesn't work like the way you might think, like 60-60. It doesn't work like that. You would actually want a harder paper. So the fact that you said it's a harder paper, that's exactly what I want from every year. I would love harder papers. Because easier papers, you can assume the top students in the state are all going to get 100. So now the scaling is going to go down. It's not going to scale well. So unless you are a top student in the state, it's not going to look good. Whereas a hard paper, across the board, everyone finds it hard, it's pretty good, because then it scales up. You get that? So I didn't walk into my exam saying I want an easy paper. I wanted a hard paper. Because then scaling kicks in. So don't think like that. Like if you get an easy paper this year, next year, if it's hard, the results would be essentially the same.
So
Does that make sense?
we want people to do bad on our exams.
Not necessarily either. It's not like that. It's not that you want it to be bad. It's that in 2001 when they made the standards, they said this is the mark that this is how it's got to always look, pretty much, to make sure that our students across the state, Australia as a nation, is not going downhill. So this is like everyone's got to get on an average of 70%. So if this year the average is 60%, they'll boost everybody's mark so that it becomes what? 70%.
But then what's the point there?
What do you mean?
Because you're saying that if
So
they
if- so
get
then if
60%,
it's 80%,
they'll boost everyone. But
correct.
then that's not saying that Australia hasn't gone downhill.
Yeah, I know,
just
but it's a
saying that
standard.
We're disguising it.
No, correct, but that is exactly what happens. What do you think that plan does and stuff like that? It's meant to show them from a up to a year 9 standard how bad or how good they're doing. By year 12 it doesn't matter, but I'm saying that's the standard. Like if there was 80, they're going to just downgrade that to a 70. So that the standard is a 70. I'm just making that number up. So you won't be disadvantaged in any way. You're not meant to be disadvantaged.
Test go home, you mark, and that's all I'm doing. I don't care about what.
But that is how it would work.
Yeah, but like,
Every
think
student,
about it,
every
and it's
student,
like, oh, what does this mean?
every
No, I
student's
don't.
going to go to uni. Like whoever wants to go uni will go into uni. That's it. That's all you need to know. Like if you guys want to go uni, you'll go uni, regardless of your mark you're going to get. Regardless. When you get 50, you'll get it. You'll go to uni. So 70, you'll get a uni. You'll get the course you want. So stop thinking that you think you're doing this
I didn't
more.
realize how many like workarounds there were to get into uni. Like I saw someone who got like.
It's not just
20
workaround. It's just you actually will directly get in. Like
No,
you
like,
guys
there
will
was someone
directly get
who
in.
got like a 28 ATAR, and
Yeah.
all they did was they did the 1 year diploma course.
Correct.
And then they still go into uni.
Correct.
And they
Second year.
didn't lose any time.
Yeah,
They went
second
in
year.
as second
I
year.
know.
Like,
So I mean
why
by
do we bother trying?
I know, there's so many loopholes. Can't I just go in? You know what I mean?
different career pathways, different universities, different opportunities. That's a good word. So if you go to the university that this person went to, his opportunities or her opportunities would not be the same as the person who went to the University of Sydney, who would not offer a diploma like that. Would not be the same as opportunity of University of New South Wales, who also would not offer that. So it depends. I don't know. It's interesting. You get in, you get a degree. Will the opportunities be the same as the person next door to you that has a better degree, better networks? I think that's what you're paying more for, networking. Yeah, you're not really paying for a degree. All right, we'll wrap it up. Oh, done. Trig is done. I think next week we'll revise. I was hoping today, but next week we're going to revise trig and simultaneous equations, which was our first lesson. And then the week after, it looks like we're going to be doing finance. We'll start finance. So that's the plan. All right, if you guys got any questions,